Here's our fractions packet, part 1, shading and naming. You'll shade the amount stated and name the fraction in words. So, we will shade in the part that says this is 1/3. You would write 1/3. And so on. You'll do that for each of these. When you get to the circles that are already shaded, you'll write in the amount. Like, for example, this one is 2 out of the 3 are shaded, so it's 2/3. Here's our divisibility rules. They're used to help reduce fractions. And let's talk about this vocabulary. This number at the top, it's called the numerator. How many things of something? It's the number of parts present. And the bottom number is called the denominator. What kind of something that is. The name of it and the number of parts in the whole. If the numerator is smaller than the denominator, then the number is less than 1. For example, you have 2/3 is less than 1. If the numerator is the same as the denominator, then the number is equal to 1. 3 over 3 equals 1. 3 divided by 3 is 1. If the numerator is larger than the denominator, then the number is greater than 1. 3/2 is greater than 1. Let's go to the next page. Shading or reducing. We're reducing the following fractions. So we have -63 over -7. That would be +9. Because basically we have -63 divided by -7. The two negatives, we divide them, cancel out this positive, and so it's just 9. If you look at some of these special situations, we have 0 over -5, that's 0. And if we have a 0 in the denominator, it's undefined, it does not exist. Anything divided by 0 is D and E. That's undefined, does not exist. 0 divided by anything except for 0 is 0. Okay, let's turn the page. Shade the amount stated. So we have 1/6, but there are more than 6 pieces. There are 12 pieces altogether, so 6 times 2 is 12, and whatever you do to one part of the fraction, you have to do to the other. So 1 times 2 is 2. So you shaded 2 parts of this fraction. Reduce. We have 4 over 6. Both of those are divisible by 2, so we could divide by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. Okay, let's look at this one, 4x over 24x. Well, x divided by x is just 1. 4 and 24 share a factor of 4, so we could divide both of them by 4. 4 divided by 4 is 1. 24 divided by 4 is 6. So your reduced fraction is 1/6. Let's go to the next page, law of exponents. Let's look at number 2. So we have r to the third times t to the second all over r to the fourth times t to the seventh. We have a fraction here, so that means it's quotient of powers. We're subtracting the exponents. So if we're to rewrite this, we have r to the 3 minus 4 power times t to the 2 minus 7 power. So we have r to the -1 and t to the -5. Since these are negative exponents, we'll flip these and make it a fraction. So your simplified form would be 1 over r times t to the 5th power. Okay, let's go to the next page here. Reduce these square and cube roots. First, you will write these down. These are your perfect squares. Let's look at the square root of 25x to the 10th. So first, we look at the number, the square root of 25. Can we pull out any perfect squares here? Yes, you could take out the square root of 25. There's just one. So the square root of 25 is 5. And now let's do the square root of x to the 10th. If we were to rewrite this as an exponent, it would be x to the 10 over 2 power. It's 2 because if there's nothing here where the index is, it's automatically assumed to be a 2. 10 divided by 2 is 5 with no remainder. So we have 5x to the 5th. That's our simplified radical. Okay, let's do one more example, this time with the cube root. But first, let's write out our perfect cubes. We have the cube root of -1, that's -1. Cube root of 8 is 2. The cube root of 27 is 3. The cube root of 125 is 5. And the cube root of 343 is 7. So let's look at one of these. Let's look at the cube root of 54. So first you want to try to take out each of these perfect cubes. There's no negative, so we can't take that one. Let's see, can we take out 8? Divide it by 8. 54 divided by 8 is a decimal, so no, we cannot take out 8 either. Now 27, if you put that in the calculator, you'll be able to put that one in. 54 divided by 27 is 2. 2 does not have a perfect cube in it, so that's it. And the cube root of 27 is 3. So our simplified radical would be 3 cube root of 2. Okay, try the rest of these on your own or in your groups. Turn this paper in by the end of class today.